This conference will now be recorded.
All right, so what we have been seeing in the last couple of sessions, so typically like 4-5 sessions, is that how you will be working on a Git workspace. That is, there will be a central repository available. So depending on your need, you're going to clone the workspace, and after cloning, you choose the branch in which you want to work. By doing a checkout, you go to the branch, and in that, which commit ID that you want to choose to work, so you can choose. And once the changes are done, try to do the staging and then do the commit. So this way, you keep storing all the changes in a particular branch that you're working in a repository, and based on your need, you're going to push or pull the changes from the respective branch of your local workspace to the same branch of the central repository. Okay, so this is what is the regular workflow, and in that also we saw how do we undo changes, how do we revert changes, how do we take backup. Now, in continuation of that, so what you are going to have exactly in your repository or central repositories full of commit IDs in a branch. Now what happens now, as you keep modifying, everything will be commit IDs. So at some point of time, if you want to quickly refer to a particular commit ID, then it is going to be difficult for us to identify. Okay, so for what purpose you want to identify? Now, as a developer, you will not be interested to identify because you will be just doing the changes in an incremental way and keep adding the commits. But when we want to give a commit ID or a change to QA, or let's say that we have released something to a customer, then we need to do something called as benchmarking. So benchmarking, or what we call it as baselining. So typically you have to mark so that I will know, okay, yesterday QA took the C3 commit ID and today they have taken C6 commit ID. So this way you will be able to tell whether the QA has actually taken a commit ID which has your changes, right? Let's assume that your change is C6, okay, or C5. Now I want to know whether QA has actually tested it. Then the only thing I can ask is, hey, whatever the product that you have tested is created on which commit ID. Now if they say the commit ID is C3, then definitely the commit ID that you have is on top of that, so you can assure they have not taken or they have taken. The same way, now suddenly if there is a bug coming up and customer has reported that there is a problem in one of the release, now you want to go back exactly to that commit from which you have given it to customer. So once again, how do you exactly identify for all this scenario? So that is where now what we have to do is a practice in which after certain use cases, like when you're giving it to QA or when you're releasing your product, you have to mark a commit ID to a level which will tell that, okay, this is what I have used it for my development or my testing purpose or for my release purpose. So such a kind of reference that you apply is what we call it as tagging. Okay, so what do you mean by tag? So in general word, tag or label. Now on your day-to-day, we would have seen that you have used tags and labels in a lot of places, especially let's say that you're buying something. All the products has some label or tag attached to it. Or let's say that you buy some cloth. Now when you buy something from the shop, typically it has a label or a tag attached to it. So what does it help? It helps you to quickly find out what material it is made up of, what is the brand, what is the price, right? All those things will be easily available for you. The same way, now what we can do, every commit ID that we have, we can apply something called as a tag to it. So that way, in Git, tag is nothing but a name or a reference name that you are applying to a particular commit ID. So that by looking at the reference name, you will be able to get the details of the commit ID. So we don't have to remember the exact commit ID. Okay, so that's how, based on your need, you can go ahead and apply a pattern or a name to a tag. So now the next question comes, okay, Now I cannot remember a commit ID, which will be a 40 characters. So you are telling me to apply a name on top of that so that it's easy. But now the next question comes on that is, how do I remember the name? Because there might be many tags that you have to apply. So that's where, again, when you're applying a tag or a name on top of your commit ID, you're going to follow some naming convention, or what we call it as a pattern. So every organization will follow their own naming convention. Now let's assume that I'm trying to follow a naming convention. Now let's say if I'm giving it as a QA commit ID, then I will just say a name called QA underscore, let's say which date I gave. Okay, and if I want, I can also give some ID which will give me my Jira ticket reference or the Epic reference, something like this. So now if I apply this, then it will be easy for me to find out what is that I've given. Or let's say you are trying to give a tag name for a release, then I can just type like capital R, which stands for a release, and then I can say which version. Okay, now let's assume that we are doing a 1.2 release, then you can just name it like 1.2. Now if you put it next, then it will be 1.3. Now this way you can typically name the tag and apply, so that now if someone comes and asks me, hey, can you tell me what is the commit ID that we have used for release 2.2, then you don't have to worry because you know the naming convention. Then all you have to do is search for a tag with this name, and whatever commit ID it has applied to, you can quickly refer. So that is how, rather than you referring to a commit ID directly or remembering it, you can refer to a tag name which will internally refer to a commit ID. So that way, tag is nothing but a name that you apply to a particular commit ID. Okay. Now, how do I apply? So this is where, once again, if you create a tag in your local repository and you apply it to a commit, then the tag will be again available only in your local repository. So that is where, is it something only you are going to use or everyone is going to use? So if everyone has to use it, then you should be creating the tag and applying it from the central repository. So that is where you're going to work on the repository manager on different tools. Okay, but anyway, I'll just show you that how you can create a tag for yourself, and if needed you can also push that. But if you want to push a tag, once again you need to have some specific permission. When you use GitHub, by default everything will be public, so that's where you will not get any issue. But as an organization, if you go, the repositories will be private, and in that we will be able to get the permission on what I'm going to do, and based on that you will be able to work. Okay, so to create a tag, you will just have to say git tag -a, then the name of the tag what you're going to give, and some comment, and then followed by the commit ID. Okay, so first what I'll do, now let's say I'll try to clone this workspace. Okay, so I'm going back to my classroom Git folder. So this is what usually I prefer, so that I remember where I'm creating the workspace. So here, okay, so let's say workspace 00. Okay, so now if I go inside it, just like branch, if you want to see all the tags available, if you say git tag, it will show. So currently there is no tag available. Now, however, if you want to create, now let's find out some commit IDs to apply. So let's take this commit ID. So what we will do now, I'll say git tag -a, a tag name. Okay, so let's call the same release 1.2. Okay, and then I'll say a comment for release 1.2 and which commit ID. So if you see now, if you say git log, here it has applied a tag. It's a dark color, but this is the tag attached to it. Now what's the benefit? Now going forward, if anyone has to refer to this commit ID, they can use this tag to refer it. So that wherever you have used the commit ID, right, instead of that, you can use this tag name. Now just to show you, if I say git show and the tag name, internally it will show us the commit ID details. You can see. So first the tag is telling who created it and for what purpose, and internally this is referring to the commit ID. So this is how at any point of time you can keep on adding tags. Okay, but when you talk about tag, especially in Git, you need to remember one thing, that is, I told you tag is nothing but you're going to apply a label, right? Just like how you bought a dress. Now let's say you're buying a dress. Okay, so can a shirt, whatever that you're buying from a shop, can have 2 tags on it? Yes, you can have 2 tags on it, but both the tags will be different tags. Like one can have the price tag and the other one can give the brand tag, or it will say how to maintain the shirt, right? So that way one tag or one commit ID can have different tags on it. However, can I apply one tag in a shirt and apply that the same tag to another shirt? That will not work, right? Because every shirt should have its own tag. The same way in Git, one commit ID can have multiple tags on it. Like let's say I have also given the same commit ID to another customer, so I can simply go ahead and apply another tag on top of it. It's not a problem. So that way one commit ID can have multiple tags on it, but I cannot use the same tag to apply on some other commit ID. Let's assume that I'm trying to apply. It will not allow. Okay, so that's where what we need to do is we need to first understand that we can apply a tag only to one commit at a time. However, one commit ID can have multiple tags on it. Okay, and by default all of them will be available in your repository only. Now if you have permission to push the changes to the central repository, you can go ahead and say push -- tags. Okay, so if you say git push -- tags, now it's going to push only the tag references to your central repository. Now this is not a good practice, because when you go to an organization, when a central repository is created, they will be giving you permission only as a regular user. So that way you will not have all these rights. So only an admin can do all those things. Suppose if I am the admin, then I can do. Okay, so now it pushed only the tags. Same way. Now tag is just a reference. So if you delete a tag, what will happen? Nothing will happen. Just like you buy the shirt, you go home and you just tear the tag and throw it off. Does it harm your shirt? Nothing. The same way, if you remove a tag, the reference is removed, but the commit ID is still going to be there. Okay, so if I say git tag -d, let's assume I'm deleting this, still you haven't done anything to the commit ID. The commit ID still remains the same. So tag is more of a reference. Now in some other tools you might call it as label. Okay, like Subversion, Perforce, or ClearCase, if you're using it, you call it as label. So label or a tag is nothing but you're going to just apply a reference on top of it. Okay, now this is pretty much what we call it as tag. Okay, so now when you're going to do tag, so whenever you complete a work, especially like when you're trying to give it to QA, we need to apply a tag so that we will know what is that exactly QA is taking. The same way, whenever we are trying to do a release, at that point of time also we are going to apply a tag. Okay, so that's how we will be able to get a reference. Okay. Okay, what's the question? Can we create a tag out of branch or out of commit ID? So tag is specifically for a commit ID, so that if you understand, a commit ID is available in the branch. This is what yesterday we were trying to understand, right? So you refer to a repo has a branch, and the branch has commit IDs. So that way you are not referring to a branch, you are referring to a commit ID always. Okay. Now let's understand another topic now. Okay. Guys, please follow the commands little later. I don't want you to try now, but this is the syntax where for a tag, you need to give the pattern. Again, this is just command line. If you are going to the central repository like Bitbucket or GitLab, it will have a UI which you can create. If not, from the command line, this is what you're going to do. Now, one of the other important thing, generally it might be your interview, right? So the question that everyone will be asking is, there's a concept called rebase. Okay. Now, what exactly is rebase? Okay. Now, rebase is nothing but a merge. Okay. So that's where first let's revisit what exactly is merge. So what is merge? So we take the content from one branch and we try to put it into another branch. Okay. So that is what we call it as merge. But for certain reasons, we have to do a different type of merge, which is what we call it as rebase. Okay, so ideally, what do you mean by rebase is? Rebase is another way of merging, but what it does is it will not be adding a new commit ID, because if you remember, when I modified in my source branch and when we tried to merge, the merge actually created a new commit ID in the destination branch, correct? Whereas when you say rebase, the rebase is not going to keep creating new commit ID. It will try to realign the branch. Okay, so I'll talk about it, but let's understand it a little bit on the diagrammatic way so that it's clear. So now let's assume you have a branch, okay, and in that branch you have some commit IDs, and then now if you create a new branch, let's say from this commit ID, then whatever is available on the particular branch, like in this case master branch, will also come to the new branch. Okay, now this is what we know that happens in our branching. Now pay close attention. Now let's assume I go to my source branch, okay, and in the source branch, like the master branch, if I do a commit, okay, and now if you have modified something in the test branch also, okay, and if you try to merge from test branch to its source branch, that is the master, what will happen? It is actually going to take this changes, that is the changes that you have on the source branch, that is master, and the branch from which you are trying to merge, that is test branch, and both of them put together, it will create a new reference, which is what we call it as a new commit ID through merge. Okay, but when you go to organizations nowadays, when I talk about continuous delivery, they will be having very short releases, and for every release, let's assume they are creating a separate branch. Then what happens? There will be too many branches that we have. Okay, now for some reason, if for a next release they don't want to create a new branch, they want to continue the work in the same branch that they had earlier. But what happens? As they keep working on the same, the number of commit IDs will be more and more. So that is where now what they want is to use a branch in such a way that when they start working, they should feel as if it is a new branch, and whatever the commit ID that they already have should not be repeating. Okay, so how are you going to solve for that? So that's where when you do a rebase, there are two levels of rebase that you can do. So depending on what is that you're going to achieve, rebase can help you to merge. As the name says, rebase means, see, for creating this branch, the base was test. Suppose if I say rebase, what it will do is, on the latest commit ID, it will feel as if this branch was created on the new commit ID. Okay, so how does it look? So just have a look here. So the same scenario, you created a branch and you modified a commit ID and you put it on the master branch. And now if you go ahead and say rebase of the test branch with respect to master branch, then what will happen is, watch this. Now, since there is a new commit ID, if you merge will create a new commit ID on the master branch. So instead of that, if you try to say rebase will create this branch, or I should say recreate the branch in such a way that the new commit ID is available, and based on that, the branch has been created. So this way, for every release, when you are trying to rebase, you are just shifting the commit IDs to the old one to new one, so that the branch looks new and you will not be having all the previous commit IDs unnecessarily. So that is where, when you want to make sure that the number of commit IDs has to be shortened for all the releases, then you will be going ahead with rebasing. Okay, so understood? When you say rebase of this, the same branch, it will just go ahead and create from the latest commit ID. If not, what you should have done, you should have created a merge, and every merge you do, it will be adding more and more details. Whereas when you say rebase, it will recreate as if the branch was created from the latest commit ID, and you will have everything. So this is one level of rebase. The same way, if I come to this diagram, and now if I want to merge from the test branch to master branch, if regularly if you do merge, then what will happen? Again, it is going to create commit IDs. So in case if you don't want to do, then if you try to do another level of rebase, then instead of merging, Git will actually create as if the commit IDs was directly happened on the master. That means it will be exactly same to what you had in the test branch. So this is how, as the name says, rebase. So rather than creating a new branch, the old branch itself, you can shift as if it has been created based on the latest commit ID. If not, you can also go ahead and merge back to the master by saying rebase, wherein it will be realigning the master in such a way that all the commit IDs was actually created on the master. So that way it will be safe enough for you to go ahead and delete the branch. Okay, so the question now comes is, when is that you are going to use this kind of method? Okay, now when you want to maintain all the history, then don't do this rebase. Always go with the regular method of merge. Okay, but whenever you want to have a linear history, linear means not everything, so you just have to cut short in such a way that only the latest is available, but all the others are added to the existing, so that if someone looks, it's not too much of confusion for them, so it feels that everything is created properly. Or like I said here, instead of having another branch created or merge created and it will create one more commit ID, so simply you can just rebase so that the branch appears as if it has been created from the new commit ID. So you will be able to get all the latest commit IDs. So the only use case of rebase is, it is be helping you to reduce the number of commit IDs rather than showing everything, because when you do a merge, it will be adding more and more. Okay, so this is the main advantage. So that now the basic difference is, what is merge? So for every change that you try to add, merge will be creating a new commit ID and it will be increasing the number of commit IDs in the history. But if you rebase, what will happen? The whole branch will be recreated in such a way that the reference will be based on the latest commit ID. so that the number of commit IDs will be optimal. So only in that case. But if you have a big product and you have too many components that in that, if you try to rebase, it's actually going to do a big mess up. So that is where if the number of commit IDs are small and if it is a quick release that you are doing, then rebase will be optimal. So typically if you're working for a service-based organization where they are trying to do something like a weekly release or bi-weekly release, then they will create a small branch, do the work, and then rebase, so that the branch will be getting recreated from the latest, and then they can go ahead and do the changes. So that way all the commit appears to be available on the parent branch in which they are trying to rebase. So that's the practical difference. Okay, now to do this, like I told you, you can typically, let's use the same branching convention and we'll try to work on this. Okay, now remember this diagram, which will be easy for you to tell even in case if someone asks in the interview. So what we will do now to work, I'll try to create a branch, or let's try to use our existing repository and let's try to do the changes based on that. Okay, so okay, so let me take this workspace. Now in this workspace, let's look. So we have these commit IDs. Okay, so let's make a note of it. So this is our master branch. Okay, so let's not worry about these things. Okay, this is my master branch. So let's say I create a new branch called test now. So if I say git branch and test, so I can go to this. Okay, so before going in, like I said, the scenario, what we will do, we will first try to create a commit on the master, and then we will go to the branch, the new branch, and then we will try to rebase. So here on the master, what I'll do is, let me just create a file called dummy1. Okay, and we'll add this. Okay, now because of this, let's go ahead and try to take git log. So we would have got a new commit ID on the master. Right, now earlier we had this commit ID. Now additionally it has taken a new one. However, if I go to the test branch, in the test branch you should see it's based on this. So if I say git checkout and test, and here if I say git log, you can see this latest commit ID is not there because it was done in the master. Okay, so keep the same reference. Now here we will create a file in this. So let's say dummy2, and let me add it here. Okay. And because of this, okay, so if I go ahead and say git log one line, so what has happened? You can see on top of this B27, it has created a new commit ID that is available on your test branch. Okay, now let's make a note of this also. Okay, so we just have both the references. Okay, so this is what we have in the master, and this is what we have on the test branch. Okay, so now let us do the rebase. Okay, so that is the first one that I said. So when you say rebase, what will happen? It will try to recreate the branch as if it was from the latest one. Okay, so for that you can go ahead and say rebase. Okay, so now I have to do a rebase based on master, because when you do a merge you will say source and destination, right? So that way if you don't tell the destination, destination will be your current branch. So that way I'm trying to do a rebase. So now if I did a merge, what would have happened? Okay, see, if I had done a merge, then ideally it should have taken this commit ID, added it here as a reference, and for that it would have created a new commit ID. Correct? Now see what happens when you do a rebase. Okay, so let's go to this workspace, and if I say git rebase master, okay, so it is trying to do the same like merge, but what's the difference? Okay, so you have got the dummy one file also, but let's say git log. Okay, so watch what it has done. This was my old reference. Okay, so typically it would have added your latest changes. Okay, so you can compare now with all the three. Okay, so what it will do, it will try to take the commit ID and it will realign it in such a way that you will feel it is actually created from the latest commit ID, because you can see it added here, because the first branch what we created was master, and from there we created the test branch based on this commit ID, correct? But now if you look, it has tried to add, and based on that change it has to realign it. So that is how first it says that this is the commit ID, and then this is the commit ID that you got from master, and then on top of that your commit ID has been created. If not, when you did a merge, what will merge do? You know, it would have taken like this. It would have taken this commit ID, and on top of this commit ID it would have taken all the references once again and it would have put. So that's where it neatly arranges, which is nothing but rearranging. So now if you look, it feels okay, you created this test branch based on the master at the current level. This is what I showed you here in this one. So we had this, okay, but when we rebased, it's just kind of recreating the branch on top of the latest. Okay, now we will try to do the next level of rebase, where we will feel that these changes are merged back to master so that the commit ID looks proper. Okay, so watch the same output. So now for this, what we will do, we will go to the master, and then we will try to do the git rebase based on the test branch, wherein test will become the source and the master will become the destination. So I'll say git checkout master. Okay, and now if I say git rebase and test, okay, and now if you go ahead and say git log, you would see the difference. So instead of just blindly adding commit IDs on one top of the other, you can see what it has done. So neatly it is saying that this is the commit ID we had first, on top of that we had, and just it realigned with the references what you had. If not, it would have been taken and create a commit ID between it. So that is where the alignment will not be proper. So everything will be in an order. So that's where you have to think whether you have to realign the commit IDs on the branch, then you try to do a rebase on top of it so that it realigns to the master. Okay, So on some scenarios, you might have to use rebase, okay? But remember, the only difference is when you try to do merge, it will be adding too many references to it. But instead of that, if you want to just have more of an optimal way of getting the commit IDs, then you will be using the rebase. If not, just think of this diagram, okay? So have the branch, but again, instead of me merging and creating another branch or new commit ID, I can just go ahead and say rebase. So it will feel as if you have created it on top of it. So that is how when you're trying to take a a flow diagram, or you're trying to create a tree, it will be looking neat, and with lesser number of commit IDs, it will be easy for you to track and maintain. But this also has a side effect where if you have too many commit IDs, then doing a rebase will create a lot of conflicts. Okay, so that's where rebase is not usually suggested for changes which happen for a longer time. So for shorter releases, then you can go ahead and use this. Okay, so this is one of the use case. Okay, now there's another question that most of us will be thinking, right? So whenever you do a push and pull, coming back to this diagram, we will always push or pull between your local repository and then central repository. But however, I told you the meaning of distributed version controlling means you can try to share changes from your repository to any other repository. That could be a central repository, but by default, we always track it as a central repository. So that's where now, if you have a requirement in which if you want to push or pull to a different repository other than central repository, that is, other than your default central repository, if you want to refer to anything else, then what you're going to do is you have to add some references. Okay, so how do you add that reference? So to show you that, now first let me quickly do a clone from my central repository. Okay, so let's say git clone. Let's call this as okay, I'm inside the folder, so let me come out clone, and I'll say workspace 01. I'm sorry, 2 times. Just for the demo purpose, I'm just quickly creating 2 workspaces, so both of them are same, workspace 1 and workspace 2. So what we will do now, I will go to workspace 1, okay, and in this workspace on the master, let's quickly create one commit ID. Now just to see that, so what is the commit ID we are currently pointing? B27. So in this, let's say I will add a new commit ID. So let's say touch and dummy file. Dummy file for demo. Anyway, so there's a dummy file created. Now if you look at the git log, so basically a new commit ID would have created on top of B27, that is 3EB. Okay, now this is on workspace 1. So let's go to workspace 2. Okay, so in this workspace, if now you say git log -1 line and -1 just to show, so this is the latest commit ID. So that's where now by default from this repository we were always referring to our central repository. Okay, so that is where whenever you are trying to do a push or pull, there are 2 options that you have to give. So one is what we call it as a reference name, and then that reference name refers to a URL of your central repository. Okay, so in order to see this, if you go to your repository, that is your local repository, and if you say git remote -v, see what it shows. So you can see it clearly tells that there is a name called origin. So origin is nothing but a reference name. Okay, so that we are clear that origin means, okay, from where it got created. And what is this origin referring to? This central repository. So that's where whenever you did the push, what it did, it pushed to this particular central repository. And the same way, when you did a pull, what did it do? It kind of took the commit IDs from the central repository. So that is where your push and pull was happening by default, because when you set up push.default is simple, it will always refer to this. So how does it get created? When you try to do a clone, from that it is going to create. So this is where now if you want to push or pull changes to a different repository other than your default repository, because every time when you say push or pull, it always refers to origin. How? That is where we had set up something called as push.default, which is simple. So it will always refer to the origin as the reference. So now if you want to pull or push to some other repository, then you need to add the reference of that repository as your remote. So remote means the repository to which you want to do a push or pull. So that's where what we have to do now is, in the repository where you want to have the reference, go ahead and say git remote add and give a name to the reference, and then where is the repository to which you have to push or pull. Okay, so in that way, now the repository to which I want to pull, right, that is 01. So what we will do, we will say git remote add. Now let me just give a name, call it as demo. Just like origin, demo is just a name, and then what is the actual URL of my repository. Now for testing purpose, it's still in the same folder, so I'm just giving the reference location. Okay, and now if you go ahead and say remote -v, it clearly tells that you can do a push and pull to origin, which is default. However, if you now want to pull and push, you can also do a pull and push to this particular reference. But how do you tell that? Because we have set the default is simple. That way it will always take the origin. So now if I want to do a push or pull to this particular reference, then when you are saying the git push, you need to also give the details on what is your reference name and corresponding branch. So this is where I told you that when you do a push and pull, you also have something additionally. So now when you do a push and pull, in addition to just saying git pull or push, you can go ahead and say a reference name, which is nothing but this. Reference name means here origin or demo, and along with that, to which branch that you want to put, that also is something which you can decide. Okay, so that's where in some of the examples, whenever they are trying to say git pull or push, they will refer it as origin and space the name of your branch, but it will be quite confusing for beginners. So that is where I told you to set up the push.default is simple, so that way you don't have to use the reference. Whenever you do a push and pull, it will always go to the central repository. But now if I want to change it, so this is where I can change using this. So now watch, in my current repository, I don't have that dummy file, correct? So now I don't have the commit ID also. So watch this. If I say git pull and I have to tell demo, which is the name of my reference, and followed by which branch that I want to get the details. Now you don't have to tell the URL because you are referring to the reference, and that reference will be getting this. Okay, so now here, if you go ahead and say master, so it will try to take the reference from your remote repository that is not your central repository and try to pull it to your master branch. Okay, so there you go. So you never worked on your central repository. Okay, so it directly took it from your local different branch. So that is how you can do a pull or push to a different repository other than your default central repository. So now if you see, I would have got the dummy file, and based on that, if I do a git log, you can see I have got this new file. So this is how, if you have to do a push or pull for distributed version controlling, that is if you want to share, you need to first set your references in the repository. Only then you will be able to change. Now I can also remove the reference and make it default. For example, let's say I'm using this workspace only for testing and I want to share it only with the workspace 01. Okay, so that way, okay, I'll clear this. So let's assume I don't want to share it to the central repository. I just want to share it to this repository. Then you can go ahead and delete this and make this itself as origin. So for that, you can simply say Git Remote RM and the reference name. Okay, so now if I just say Git Remote RM and origin, okay, it will delete, and then I can also delete demo. Now there will be no references, so you will not be able to do push or pull now. So that's where first you have to again add it. So I'll just say Git Remote Add, and now I will make origin, and the origin I will refer to this. Okay, so here by default, if I now do a push or pull, it will always refer to this particular repository. Okay, now we saw pull, so let's do a push from this repository to the other repository. So if I want to do that, now let me quickly create a new file here. So I'll say touch dummy file again. Okay, so it's just another file I'm creating. Now quickly let's add it. Git commit. Now because of that, if I say git log, so we will have a new commit ID which is 68, right? So now if I want to push to the central repository or the repository that we had mapped, then all I have to say is git push and origin master. So now what is our origin? If you look, the origin for us has been changed, so it will go to this one, not our central repository. But there is one catch here, especially when you are trying to do on a local repository, because this is not your central repository. So there is a term in Git which we refer as bare repository and non-bare repository. So all the central repositories are called as bare repositories. So the meaning of bare is nothing but you are going to use it only for sharing and storing, whereas all your local repositories are called as non-bare repositories. That means you can modify and store and share. So whenever you are trying to do a pull or push, which is not a bare repository, but if it is a non-bare repository, so in this example, if you see, it is our local workspace, another local workspace, but what is the type? Non-bare. So whenever you are trying to do a push to a non-bare repository, what it expects is on the non-bare repository, you should not be defaultly checked out the master. So what is that? I'll show you. So when you're running this, it is saying that in the branch to which you are, or in the repository that is non-bare repository, when you're trying to push, it is saying you have currently set the default branch as master branch. So that is where when both of them are working on that, it will not be able to push. So for that, what I should do is, let me just go to that workspace. Okay, and you can see by default it is master, right? Now I'll just check out to some other branch. So we had this iOS branch, you remember? So now the working branch is iOS, right? So let's go back to Workspace 2, and from here, if I say push, it goes clearly. Okay, so this is how you can set up a remote repository, so that instead of referring to your default central repository, you can typically do a pull and push to another repository. So that is how the distributed works. So if I come back to one, so in this one, if I say git checkout master, okay, so you can see this file is available. Okay, so this is how what you can do. You can typically try to set a remote as a reference, and based on that only you will be able to do. Okay, so if not, for all those who have tried the pull and push, this is where the examples that you will see outside. Now typically this is what, even when we are trying to do a pull or push, you would see something like this: git pull origin master, git push origin master. So that way, what is this origin? So the origin is nothing but the name of your reference, okay, which internally points to a particular central repository. So now in this, if you see, it still points to the central repository. So that is how when you work, you have to say git pull or push, and then the reference name, and followed by the branch to which you want to work. But before that, you need to make sure that the remote add as a reference is available. Okay, so this is something that you need to understand. Yes, you can push to a different central. The only thing, like I said, now I don't have another central repository. So just to show you what I did, I just cloned two workspaces and I modified. But however, if you want to push to another central repository, then you need to have permission on that. And all you have to do is say git remote add, and what is the reference name that you want to give, and for that, what is the central repository URL. So if you change it, it will work. But if you want to always go to that, then like I said, remove the initial origin reference and then make your new reference as the origin. So that is how you can push it to a particular non-bear repository or a central repository. Okay, so okay, if someone wants clarity again, see, in Git we have two types of repository. One is local and the other one is central, right? So all the central repositories are called as bare repositories, which means you will be able to only store and share. However, all your actual workspaces in which you are working, like in this example, we were working, right? All the cloned ones. So these are called as non-bare repositories. Just to put it up. Okay. So
yes, thank you.
Central repos are called as bare, and all your local repo are called as non-bare. Okay. Now the difference is, in this you can modify as well as store and share. However, if you have a bare repository, in this you are just going to only store and share. Okay. So these are the basic difference. And now some people might talk in this terminology that you need to just understand. Okay, fine. So pretty much from the user level we have spoke a lot.
Yes.
And there is one small thing that I think even I missed it, is, what was that? Ignore. Okay, so what exactly is ignore? Now in the beginning also I told you that when you're creating a repository, it will try to create a file called ignore. So what exactly is this ignore? See, what happens now when you are actually using it for your development purpose, or let's assume you want to give the product to QA, then someone has to do something called as build, right? So build is nothing but whatever the source code you have, you need to convert it into a object file and create a product, which is a deliverable, which could be a jar or a var, right? So that way, now when you are trying to work in such a scenario or try to do the test, all those files that will be created during runtime will be available in the same folder. Okay, so now whether I'm a developer, I'm trying to do a unit test, or I'm trying to do a build and give it to QA, or as a QA engineer, I'm trying to run some test cases in the same workspace, there will be multiple runtime files which will be generated. So that's when what happens, by default, if someone does a git add, all those files will be added. So that is where, if you do not want git to consider some type of files for any kind of operation that you're doing using the git command, then in git there is a file called .git ignore. So dot represents hidden file. So if you create this file under your repository and put some file name, then whenever you are working, if that file name appears in the git commands, then git will completely ignore them. Okay, so now here, so there is no such file. Now for example, watch this. Assume that when I do a build for 1.java, I might get a file called 1.class. Okay, and then for 2.java, I might get 2.class. So this is where, when you try to say git status, it is referring to this as untracked. That is okay, but it is considering this. So that's when, if you say git add dot, okay, it will try to take both of them. Okay, so now for me, in my repository, when I'm working, I don't want git to consider any type of class file. So that is where you can specify one file, or you can specify a pattern, or you can also specify a subfolder in which it has to ignore. So all of them as a pattern that you can specify. So if I do not want git to refer to all these things, then we need to add a file called .git ignore, and in that put the name of the files or the pattern of the file. Okay, so now let me unset this. So I'll just say git reset, and I'll say mixed. So it's just going to remove from the staging area, but however the file is still available. Okay, so now here what I'll do, I'll create a file called git ignore, and I'll put star.class. So what I'm doing here, so I'm trying to create a file, and inside that I'm putting the content called star.class. So now watch this. If I say git status, it will never consider it. Okay, because even though those two files are there, same way, if I go ahead and say git add, it never takes the class file. Not just that, I can go ahead and create another file also. Let's just, for dummy purpose, I'll create another file. Even now, if you say git status, it will never consider. So that is how you can ignore any number of files or a pattern or folder and files inside it. Okay, but the logic you need to understand is this git ignore is again a file that is available in the repository. So that way you should add the git ignore file as part of your repository. So that is when you are creating a new repository, right, at that time itself you have to choose, so that you will not be able to get the difference. But however, every time you modify or add some file into this git ignore, then make sure that you add that also into commit and push it to the central repository, so that anyone else tries to clone this workspace, they should also be getting the same functionality. Okay, so that's where you can go ahead and say commit. So now in my workspace, no matter how many class files that I create, it will not at all consider it. You can see. So this is how, what are the type of files that you want to ignore from your workspace. So that way you can set up those files. So for example, if it's a Java project, then I want to consider only the .java files, or if you have a property files, but any other files if you just want to ignore, then based on your need, you're going to just add the content in the git ignore file. And if this is stored in the repository, Git will never consider. Okay, so this is one of the things that you can do. Okay, so remember, Git ignore helps you. Now, especially for those who are trying to do a build, there is another problem here. If, let's assume, in my workspace, now there are some other log files, right? Now let's say that I have some log file here. Now what happens? Now this is not added into the repo. Because of that, or sorry, it's not added to the git ignore file. So because of that, it is showing. Now, sometimes when you're trying to do the build, you want to delete all the runtime files. So all the runtime files are generally called as untracked files, right? So if you want to do a clean build, so this is the word what you will be using a lot of time. So what do you mean by clean? So clean mean whatever the object or the runtime files that you have created in the previous build, if you want to delete everything in Git, what exactly is that? You don't want to delete any of your source code, because let's assume I modified a file, I did a build, and it generated some logs or my object files. Now I just want to change my source code again, but if I do a build now, it will not try to build everything because there is already files available. So that is where it will try to just do an incremental build. So now if you want to do a clean build, which is nothing but you want to delete all the untracked files, then you can go ahead and say git clean. Okay, now git clean, if you say -n, it will show you what are the files it is going to delete as a dry run. Now using this, if you forcibly delete it, you can see it will delete only the untracked files. So that way, especially for the build purpose, if you are trying to write a script or some automation which would require to clean your workspace, that is only delete the runtime files or the untracked files, then you can go ahead and use this git clean. Okay, so this will be quite helpful. Yeah, you cannot ignore the .git ignore file itself because it's a concept, and it is also actually getting added in your working directory, because you see anything that goes inside the .git folder is called as repository, but anything other than the .git folder is everything treated as your working directory. So this is the diagram. So anything which is outside the .git is considered as your working directory. So that's where it is going to make sure that this file is also considered as a file. But why do we hide it by saying dot? Because it's not a regular file, it's a special file which I don't want to modify every time. Okay. Clear so far?
Yes.
Hi, Adam.
Yes.
Yes.
Yeah, it's clear. I have a small doubt in the rebase. Rebase is nothing but linear format which you are bringing in. Okay.
Bala, can you just keep the questions a little later? I just have a few more topics. Then
Sure.
you will not have that. Okay.
Sure. Thank you.
So probably I'll come back again. So now quickly, if you go back and understand the basic difference, right? So this way, now if you're just going to compare with any other version controlling system or Git, first thing is Git is distributed version controlling. How? It's not always that you have to push and pull or share the changes to a specific central repository. You can check and you can push it to a different central repository or a different user's repository, which is non-bear repository. However, every workspace in Git has its own repository. So because of that, you have the complete freedom of doing all the checkout and commit and all the commit IDs will be available in your repository. So based on your need, you can share it to a particular repository, and it gives you a lot of flexibility in creating branches, but everything will be available in your local repository. So you can create as many branches that you want. Okay, but however, what we have been talking so far is only from the user level. But anyway, as an organization, if you want to set up the entire continuous development, then it's not just sufficient that you work on the client side, because all these things what I'm talking about is client side. Client means in my machine, I just have to install the Git, and based on a central repository, I will start doing all this work, and I will be able to manage, undo, change. Depending on my need, I need to push or rebase, all those things I will do. But as an organization, when we have many people working, now I need to have a lot of access control limitation. So who should be working, who should not be working? In fact, now, like I said, you also need to know which is the actual branch you should work on, which branch you should not work on. Okay, because people cannot just directly push anything to the central repository. They cannot just create anything they want and push it. They are free to do all those things in their local repository, but when it comes to the central repository, we need to maintain everything as an order. Okay, so that's where the central repository management comes in. Okay, but I don't think I have time to talk about it. But anyway, I'll talk about the process. So now here what happens is, if you go back, we were talking about the continuous development. So in the continuous development, now I need to make sure first my organization is planning my release based on an agile way, and everything has been considered as an epic, and you have started tracking all the changes as a user story and the particular task, and then you set up a distributed version controlling system. So that is where is the central repository where you will be using Bitbucket or GitLab, and from there we need to start allowing the users to work. But before that, you need to actually set up something called as branching strategy, because now if you understand, even before a user has to start working, the first thing he need to know is what is the branching strategy, correct? So based on that, they will be choosing what sprint they are working, and for which sprint or which epic they are working, what is the branch that they have to do. So that's where we need to understand the branching concept. Okay, now what exactly is branching concept? So the first thing that you need to understand is, if you have a repository, no one should change, or no one is allowed to do a commit in a master branch. Okay, why? Because master branch represents that the code whatever you have in this branch is a stable branch, and most of the time whatever that you are giving it to a customer should be given from the master branch. That is where we call it as a branch from which I can do a release, or any branch that I want to create, I should be referring from this. So that is where this acts as the one place of source of truth. Okay, or in the other way, it is the stable branch. But where I am going to do the changes, so that is where what you need to now know is, you need to create branches, so that based on your work you have to create branches and modify the changes there. So that is where now, as we go to all the organization, they are reducing the release cycle, right? So that is where now when we are working in an agile methodology, what organizations will be doing is, they will be calling all the releases as feature releases. Okay, so that way now the epic whatever that I told you, right? For every epic, we are going to create a new branch called as a feature branch. So that way, first you need to understand, for one release, how many features that you are going to have, and for every feature you are going to have a separate branch, so that whatever the teams are working in each of the feature, they will be able to use their own feature branches and do parallel development. Okay, so it doesn't conflict with anyone else. So that is where what we are going to do now is, for every release, first find out how many features you are going to have, and based on that you're going to create several features. So that is when, if you are having multiple features being given on the same release, then again how it will work. So that's where one of the thing what we will do is, we will first create a separate branch called as release branch, because from this branch we will be creating whatever the feature that we want as feature branch. Suppose let's assume that I have two features that I want to give in a release. Then we will try to create first a branch called release branch from the master, and then from this release branch we are going to create two separate feature branches. So now what happens, whatever the developers that they are working and all the sprints that they are going to work the functionality, that will happen in the respective feature branch only. So now if I have a group who is focusing on a particular user story and they want to work on a particular feature, then they should be allowed to work only on that feature branch. So this feature branch becomes the developer branch for that particular group or that feature. Same way, whoever people are interested to work on the feature Y or the another feature, they are going to modify everything here. Okay, so this way everyone will be modifying the changes, and typically for the first time when QA has to test, they will also be doing the testing over here. Okay, so that way the functional testing will happen on the feature branches. But as we move towards the end of the sprint, if you understand, I said you will be having different kinds of testing. Okay, for those who don't understand the testing, probably I'll take it up later when we go through CI process. But now typically for others, when you go to an organization, you will be having different kind of testing, right? Unit testing, functional testing, and then regression testing. Right now, majorly the unit test is something which the developer will do on this branch, and the functional test which QA has to do will also be done on the same branch, because for all the sprints they will be using the same branch. And then when they are actually ready with all the changes, and when you want to do an integration testing like this, then we have to basically merge. So that is where they will be merging from the respective feature branches to the parent branch from which we created, which is the release branch. So in this, your integration test will be happening. And then if everything is fine, then what we can do is, either we can release it directly from this branch, like take the code from the release branch, or in some companies they will not call it as release because they want to always release from the master branch. So in that case, this branch will be called as integration branch because you're just adding it. Okay, now if you do not have too many features, then I don't need a separate branch, so I can directly create the feature branch from the master branch. So that is where in some organization they want to keep it simple. So but depending on the need, you're going to create a branch which is needed for integration or release, and then separate feature branches which will work, and then you are going to merge it. Okay, and then if you are trying to do a release from master, or you are also doing the release from the same branch, you still have to merge the code to the master, so that all the stable code after your integration testing or UAT testing should come to the master. So that's where there will be another merge that you will be doing. So that way, if you want to release, then you're going to do the release from your master branch. So this way, now if you understand, for every release you need to create this branching strategy. And suppose if there is another parallel release going on, then you will also have some branch exactly like this, where people who are working on the first release should go to the respective feature branch of the release. And the same way, if someone has to work on a parallel release or a parallel feature for a different release, that you're going to work. If not, now if they are working on one release at a time, then once the release activity is completed, your testing is completed, and the merge is completed, and then the release happens, then they will create a new branch, and from that new branch, what are the features that you're going to work for the next release? For every feature, they are going to create a branch. So this model where the branches that you create for a particular release to work on a feature is what we call it as feature branching model. So this is one of the latest model most of the organization will be using. Now this can be of different types, but this is just a simple way I'm trying to tell. Okay, so that you can also create it directly from the master, but you will always have multiple features. Then to allow all of them to work together, you're going to follow. And remember, whenever we say feature branching model, all these branches are called as short-lived branch, because once the release is done, you're not going to touch it again. So you're going to again create a new release branch for the upcoming release, and in that you're going to start working on the feature branch. When you are trying to use this method, you will only do merge. But that is where, now think, you are working on a product where there is only one feature and only one release. You modified, so you will create the feature branch directly from the master. But after the release, when the code has been merged, so let's assume you want to do another release and you want to use the same branch. So that's where you're going to do rebase. So that again, instead of creating commit IDs and tracking too many changes, if you do rebase, it will quickly do. But if not, in this model, you always do the merge. So this way, in a feature branching model, for every release, you will have a release branch, and for every feature, you're going to have a specific feature branch. And it is short-lived, which means at the end of the release, you're not going to use this again. Okay.
I have a question for this feature branching model.
Yeah. So now, this is more for the modifications or the changes that you're doing on the current release and for a committed release. But what happens sometime, there might be a previous release that has done and there will be a bug fix you have to do. So how are you going to manage that? So that's where now, as a developer, he will be doing some code and he will be having a separate epic for fixing a bug. So that is where we also have a release which is called as bug fix release, or there will be a release which most of the company call it as one-off release, or a quick patch, or a hot fix release. So what is the meaning of that? So there is some problem found in a previous release, immediately you want to do some changes and try to release. Then once again, for that we have to have a separate branch. So in that way, what will you do? Now typically, depending on which commit ID that you want to create a branch, you can go ahead and create a bug fix branch, so that now someone or the group of developers can start doing the development directly in this. And once they complete everything, they should just go ahead and do the merge to the master, and then you can go ahead and take a release from this. So this is how in the future branching model, you're going to have parallel branching possible, and all these branches will be short-lived, so that once the release is done, you're not going to use any of these branches. So again, you're just going to create another branch. So this way, you need to decide on how many releases you are working for the same product, and for a particular release, what are the feature branches that you're working. So based on that, you can create an integration branch or a release branch and merge accordingly. So now the whole next process comes in is, based on this model, how many sprints that you are having, and based on the sprint, when are you going to merge? Okay, because sometimes there might be a requirement from one feature branch to another feature branch. Then you might have to also merge, okay, from one branch to another branch. So then what will happen? Once you have merged, then you will do a merge from this branch to this branch again. Okay, it is called as reverse merge. So depending on the complexity of a product, you might have to do the merge, but if not, you will try to merge at the end, and that's where you will be doing your regression or the high level integration testing, and then UAT. All those things happens after that. And then with this branching convention, now you need to understand next is, when I create my repository, I should have all this available. So that is where now we need someone to maintain the central repository. Like this, there will be many products. So we need someone to take care of all the repositories and make sure that not everyone will be able to check in the branch or modify and push it to master like how we did it. Someone in an organization should never do. So when he tries to do a push, it should not allow him. So what is that we have to do? That's where we call it as locking the branch or code freeze. There are different names that they keep. So how do you make sure that no one pushes to central repository? How do I make sure no one pushes to the release branch? Or how do I make sure once the sprint has been completed and when we are doing ahead or going ahead with our actual testing and regression testing, I don't want a developer again to go ahead and commit it here or give a merge? Then how are you going to make sure these branches are locked, right? That is what we need to understand. So again, all those things should be done from the central repository. And it's not just that you should be allowed to push, you should also be not allowed to do the merge. So that is when we need someone called as an administrator for the repository, and we need an administrator for the tool using which you are going to manage the central repository. Okay, so there's a whole lot of other process that you're going to do. So that's where, depending on your need, you can say that you have just worked on continuous development wherein all this process has been used by you. Because as we move forward, we will be able to see that this is one of the process if you're working on a release. But if you're working on operation side, but still you have to follow some kind of branching, and that is where there will be a different branching that we will have to understand. But this is more from a particular release. So as a developer, someone has to work, so you should know what is the branching strategy, so that if I have to start working on my epic or my user story, this is the first thing I have to get it done. And based on this, we will allow the respective users to start writing their code and then store it. Okay, so that's where you will be having other set of work to manage your central repositories. But anyway, this is one of the simple and the best method what every organizations will be following, which is called as branching model for features. Okay, or simply you can just call it as feature branching model. So that's where the whole part of continuous development comes into the picture. So it's not just about using Git and 2 commands and you just say that I've done my Git or continuous development. You need to understand there's a whole lot of other process what will happen. Okay, anyway, so this is what something that I wanted to talk about. Okay, so I'll stop the session.
Question, Adam.